Okay, students are really happy that I'm going to take class in this Google way, and really happy to meet all of you. And in this Google class, I am going to take very important topic, and that topic is the kinetic energy of rotation of a rigid body. Kinetic energy of rotation of a rigid body. That's what I'm going to teach today. Okay, so let me present my screen now. I'm going to open my screen. Yes, it is like that. Yes, now it is opening. Okay, right now the screen capture and then sharing the screen. And now I am really happy to see you in this wonderful day to talk about the kinetic energy of rotational body. That's what my topic today. Okay, kinetic energy of a rotational body. Right now, let us take the slide. Now look at that. Let me close this and then let us open this screen now. Okay, the kinetic energy, we know what is a kinetic energy. Am I correct? So kinetic energy, physics people say that it is nothing but half into mv square. If you multiply mass by v square and then divide by 2, what you will get is called the kinetic energy. Okay, so that's what we are finding out for a rotational body. Suppose a body is there and it is rotating left and right. Uh, what would be the kinetic energy? That's what we are interested. Okay, now let us take the screen now. In that screen, this is what fixed axis. Okay, yes, it is fixed point, and here is small mass. Okay, so this small mass, that's what we are seeing there. Then afterwards, we have to change the cursor on, only then I can show it to you, otherwise we cannot. Yeah, now it is okay. So this is what we are seeing there. This is a fixed point on this rigid body, and this is what a small mass, that m I am taking there, small mass I am taking as m. Now some problems there. Small mass m here, and the point is p. Now let us take the angular velocity is theta dot. Theta dot is angular velocity, that is rate of change of angle with respect to time. That's called what we say the angular velocity. So when the body is moving from right to left with the angular velocity as d theta by dt, what would be the kinetic energy? That's what our aim here. Okay, so kinetic energy, we know that here G is a gravitational force and this is a rigid body. Our aim is to find the kinetic energy when the body is rotating from right to left. Okay, so let us find out that. Yes, now we know that if you take mass here, small mass here, then what would be the the kinetic energy of this? What would be the kinetic energy of this? Okay, so kinetic energy of the small mass would be equal to Ke of P. P means small particle with the mass m would be equal to, you understand, that is half mv square of mv square, where m is the mass of this particular small particle. Now what would be the mass of Ke of the body? Okay, Ke, kinetic energy of the total body. The total body we are interested. Kinetic energy of the total body I'm taking as A. Okay, so kinetic energy of total body, total body. Kinetic energy of the total body would be equal to the summation we have to take here. Let me get summation 1 by 2 into m into v square. The summation is summation of all the particles. We are seeing this is small particle p. So like this, here, all the particles are there. If you take the summation, then only we can get the kinetic energy of the whole rigid body. That's why we are taking here the summation. Now the velocity here, the kinetic velocity, am I correct? So kinetic velocity is equal to, you must understand that kinetic energy or the velocity components is equal to r into theta. That is here v is equal to r into theta dot. That is what the velocity. Okay, so if you substitute that, what you'll get here, you have to substitute this here, and then you will see that is equal to summation of 1 by 2 into m v square. In the v square we are putting r into theta dot the whole square, theta dot the whole square. Okay, now we expand this, what we'll get, if we expand this, we'll get summation will go here 1 by 2 into r into theta dot square, r into theta dot square. This also square, summation will come here, and the next step we can take the summation 1 by 2 into theta dot square, here m also would be there, theta dot square into theta dot square into summation of m into r square, summation of m into r square. Okay, so this we can write it as 1 by 2 into theta dot square into mk square, m into k square, where mk square is the ma of the body about the fixed axis. Any fixed axis, that is what the moments of mi, moments of inertia of a fixed axis with respect to this particular rigid body. Thus we can find the rigid the kinetic energy of rigid body. Okay, so this is the way we can get the kinetic energy of any rigid body. Okay.